Let's now consider what a surjective function is. And let me remind you very quickly. So now we are moving on to the second kind in the first dimension over here, right? So we talk about injective, which can be either partial or total. Similarly, for surjective, it can be either partial or total, right? The similar kind of idea about the two dimensions, we can categorize the functions. Okay, let's now move back and let's see the definition for what a surjective function is. And a function f, either partial or total, is surjective, or we say onto function. This might be the term you have heard about before in your earlier math course. Anyway, so f is either, you can say surjective, or you can say f is a surjection. If f maps to all of the members of T. Okay, so T is the second set from which we actually build the function. Okay, let's see the formal definition. So f function will be surjective if and only if the range of f is exactly equal to T, right? So here, f is actually built from the two. It's more like a relation that's built from two sets, S and T, as we have been using S and T, as the first and second sets. And the second set must be equal to exactly the range of the f, right? It's a simple definition. So let's see exactly how to exemplify them, okay? And I'm going to talk about, like before, I'll talk about the partial one, and then I'll talk about total one. And let's now go on to the example illustration over here. And I'll leave this definition of surjective function handy for you. And let's now talk about partial followed by total as before. Okay. And syntax first. How do you write it on paper? And you can definitely see the ASCII characters on the slides. Okay. I'll let you look them up. Okay. As before, let's now try to rationalize the syntax over here. Okay, first of all, you can see this is our total function over here. Sorry, this is our partial function, and this is our total function over here, right? And the essence about being surjective is about the range being exactly equal to the second set from which the relation or the function is built. So that means we are more concerned about the domain. Sorry, we are more concerned about the range, as opposed to in the case of injection, we are more concerned about the domain. So that there should be a double-headed arrow rather than tail, right? So that means the way we actually write it would be exactly like that. We just put an extra, like a arrowhead, okay, double-headed arrow, and we just put an extra head over here. Right, so this is the partial surjection with two heads, and also this is the total surjection with also two heads over here. Right, you can see this is the symbol for partial, and that's the symbol for total. Okay, a partial surjection and a total surjection. All right, let's now go over the example together. Okay, the first one, let's now highlight. So I got two examples over here. The first one. This one over here, okay? Because you can see I'm using a subset relation over here, okay? Let's see this. Is this surjective? Well, we got to look at the range. B here, and okay, so you can see the range B here and also A here. Oh, by the way, I'm assuming that you know how to judge whether a set is actually a function. You definitely can tell it's actually a function, right? Well, is it a partial function? It is, because 1 and 2 over here is a subset of the first set over here. It is a function because every domain value can only map to at most one value. Well, every value in the first set can only be mapped to at most one value in the range, right? That's something I kind of assume you know how to do. Just make sure you know how to do it. Okay, so it is partial, and then is it surjective? Indeed, B and A together is the range, which is exactly equal to AB over here. So that's surjective. And let's now look at a second example for partial surjection. Okay, let me highlight it, and it's over here. Is it partial? It is. 1, 2, 3 is a subset of this first set, and this happened to be total as well, right? It's okay for a function to be partial and total at the same time, right? And is it surjective? It is. B, A, B together is exactly equal to the set, right? the second set over here, right? That's also surjective, right? It's pretty straightforward. I think to really judge whether or not a function is surjective, it's more straightforward than judging whether or not it's injective. All right. Let's now take a look at the second example. Okay, the second line. Let me use green over here. I only got one function over here to consider. This one over here. Okay, is it partial? 2, 1, and also 3 is a subset of 1, 2, 3. So it is partial. All right. And then is it surjective? Well, you can see A here, and also A here, right? Altogether, is only the range of the function is only the range of that particular function is only just A, right? Which is not equal to the second set, so it is not surjective. So that's why you see over here, not a member of. And by the way, is this function injective? Just a side question for you, just for your benefits. Is this injective? Well, it is not, because you can see the same second elements are actually mapped from unique 2, 1, and 3 domain values. So that means it is not injective. Just by the way, right? Let me just write it down. Also, not injective. Right? So this is not on the slides. I thought I might just mention. All right, the third example that we can consider over here. Let's say this function over here. Oh, sorry, too much. Only here. Right, similar idea, right? You can see here, is it partial? 2, 1 together, a subset of this, which is good. And surjective, no, because we only got B and B over here. Together is only B, not exactly equal to AB. All right, so we just write it down. So B here and also B here, the range value. So the range of that particular function over here. So this is not exactly the right syntax, but just as a sketch, so you know what I mean. So the range of that is exactly equal to B, which is not equal to this second set. So it is not. Okay. Right. So for both of them, you can see that they are partial, but they are not surjective. Okay. Let me just write down the second one. It's actually partial, but not surjective. And similarly, for the second one, the pink one, it's also partial. That's not an issue, but it's not surjective for the reason that we already went through. All right, let's now go on to total surjection and its example. All right, the first one to consider, let's say here, again, you can see I got a subset relation, meaning that I got multiple examples to show to you, right? The first one, this function over here, only up to here. Okay, is it total? Domain values would be 2, 1, and 3, which is equal to the first set over here. So that would be total, definitely. It is total. Okay, and what about surjective, being surjective or not? A here, B here, and also A here. Altogether is going to be AB. So that will be exactly equal to the second set. So that's also surjective. And for the second one, it's going to be similar. Let's just go over that quickly. Okay. And for the second one over here, is it total? 2, 1, 3. Altogether, exactly equal to the first one. And the range, is it surjective? B, A, and B. Together, it will be AB, which is exactly equal to the second set, right? They are both of them are total and surjective. That's why I'm using a subset relation here, right? Let's now take a look at the second one. The second one here, let's say this one, oh, too much. This one over here. Is it total? 2 and 3 is not equal to the first set, right? You can think about the domain of that particular set is actually equal to only 2 and 3, which is not exactly equal to the first set. So it is not total. Not total. Is it surjective though? Surjective, you can look at the range value. So that'll be A over here and also B over here, which is actually equal to the second set. So it is surjective. But it is surjective. Right? You can see we're going to look at the two dimensions orthogonally, one by one, independently. Final one, this one over here. All right, let's now take a look. Again, let's judge one by one. Is it total? So we got 2, 3, and 1, exactly equal to the first set. Indeed, it is total. Okay, and then let's see over here. And what about being surjective? Well, look at the range value. A here, and also A here. Well, it's not exactly equal to the second set, right? You can see the range over there is actually equal to A. So that's not exactly equal to the second set. So it's total but not surjective. All right, so that's easier walkthrough because I think the definition for the surjective is not tricky at all. I think in some ways it's easier to judge than injective. All right, let's now go back. And as before, the only thing I didn't show to you is about the ASCII character for partial surjection. Right? You can see this is the plus we usually use for partial function, and then we got a double-headed arrow over here to say we are focusing more on checking the range for surjection. Right? Notice that the dash over here happens after the plus, and before the plus there's no more character. Just be careful. And then for total surjection, here you can see double arrow over here, right, for surjection, and then it's a total function over here. We got 2 dashes. All right, so that's about surjections, and we're going to move on now to the final kind of special functions, which will be bijections.